Thanks everyone for attending. I'm David Oaf with Preferred Utilities. Today's webinar is sort of the basics of fueling systems for diesel gensets. I've given this presentation a couple of times at ASPE technical luncheons. So if you are an ASPE member in Houston, San Antonio, or Austin, this presentation may look familiar. So first, we're going to talk about the requirements for a successful fuel handling system. We need to reliably supply fuel to all the connected gensets. We need to prevent overfilling a tank and causing a spill. We need to detect leaks and provide the appropriate responses. We need to communicate important information to the facility. And we need to make sure we adhere to all the national, state, and local codes at a minimum. The three national codes that we need to follow are NFPA 30, NFPA 37, and NFPA 110. There are sometimes state and local codes too. California has its own codes, Florida has its own codes, and New York City and Chicago have their own codes too. So you need to be up to date on the national codes, and then if you're not sure about the local codes, Preferred has people in all these locations that are very familiar with what the fire marshal recommends. And the authority having jurisdiction is usually the local fire department compliance office. They're the ones that have the green tags and the red tags that will tell your customers whether they can use their new fueling system or not. So corporate wants you to spot the difference between these two pictures. This is the only meme I'm going to use in this presentation, I think. But anyway, the point is diesel trucks and diesel gensets are actually very similar from a fueling point of view. Both the diesel genset and the diesel truck have a diesel engine. Both have an onboard fuel pump. That pump draws fuel out of a local tank and then uses the excess fuel to cool the fuel rails on the engine and then returns the excess fuel back to the local tank. This process is the same whether the genset is on top of a belly tank or if it has a nearby day tank. From a fueling perspective, belly tanks, sometimes referred to as base tanks also, are very similar to day tanks. But if the generator is mounted on top of the tank, please refer to it as a belly tank or a base tank. We see a lot of drawing packages and specifications that use the term day tank to refer to belly tanks. And sometimes it's not clear from the drawings and specification what the engineer really wants. And when we're bidding a project, we really hate to guess. There are a few differences between belly tanks and day tanks we need to account for. Belly tanks are ordered with the genset. Most gensets are direct fill, meaning the fuel truck pulls right up to the genset and the driver fills the belly tank just like filling up a diesel truck. Direct fill tanks are only required to have two float switches in them, a 90% alarm and a 95% switch that shuts off the fill pipe. Remote fill tanks need four switches, a 50% pump on, an 80% pump off, a 40% emergency low level, and a 90% emergency high level. Those percentages are what Preferred uses. For remote fill tanks, that's not actually something that's in code. So sometimes I see day tanks made by other people that have those switches at slightly different levels, but those are the levels we recommend. If a genset is going to be remotely filled from a transfer pump set pulling from a main storage tank, you need to specify the four switches in the belly tank. This is actually the old version of our PLS switches. We just are finishing up a product revision to the PLSs where we can fit the switches closer together now. So this slide says that to fit four switches in a belly tank, it needs to be at least 14 inches deep. We can reduce that to 8 inches now. And the other exciting thing about the new PLS switches is that they can be ordered with a quick disconnect switch. which allows us to uncouple the wiring at the quick disconnect and then take the PLS out for inspection, test it, and put it back in without changing any of the wiring, because there's only one way that the quick disconnect fitting can go together. But if a preferred salesperson bids a project where we know we're not going to be supplying the day tank, or if we know it's going to have a belly tank, there's a diagram like this that's put in the proposal so that it can be passed on to the people doing the genset, so they understand what we need for float switches in the belly tank to coordinate with the transfer pumps. So a few more differences between belly tanks and day tanks. Belly tanks don't add to the genset footprint, which is the main reason they're so popular. Day tanks sit beside the generator and take up some space that we need to account for. Day tanks are limited to 660 gallons indoors. You can actually have two 660-gallon day tanks in one room. If you exceed that, NFPA is going to require that it be a fireproof room. Belly tanks, which are usually on outdoor gensets, are available in much larger capacities. I've seen 5,000-gallon belly tanks. And like I showed you on the previous slide, belly tanks need to be coordinated with the fuel system supplier. Day tanks are provided by the fuel system supplier and will be coordinated with the fuel system controls. It may sound like a small thing, but we have had projects where a contractor provided their own day tank, and some of the switches in the day tank were normally closed in the down position and some were normally open in the down position, and we programmed for all the switches to be closed in the down position, and the pump controls wouldn't work, and nobody on site could figure out that the reason was that some of the float switches were backwards. It's not rocket science, but not everybody has troubleshooting skills. So a little more information about the genset fuel pumps. They flow 3 to 4 times the generator consumption, and the excess fuel is returned to the day tank or belly tank. That returned fuel is used to cool the fuel rails so it can be 30 to 40 degrees warmer than the fuel coming into the pump. Genset pumps are positive displacement gear pumps, but they can only lift fuel about 6 to 8 feet. So it's important to have a local fuel supply. I sometimes see designs where the day tank is located on the opposite side of a room from the genset with overhead piping in between, and that's asking for trouble. We can calculate what the drop is going to be in that pipe, but unless you have the make and model number of the genset fuel pump, which is difficult to find sometimes, you're never going to know if the pump has the capability to pull oil across that distance. So we always like to have the generator sitting right on top of the belly tank or the day tank immediately next door. On the opposite side, genset pumps can't take more than 8 to 10 feet of oil above the pump. This usually comes up in the rare case where we are supplying fuel to gensets using a supply header without day tanks or belly tanks. By the way, if you have questions, put them in the chat and we will address them at the end. And we'll be able to take all your questions at the end. We're going to leave time for questions so we don't go over an hour. So gensets can be ordered complete for direct fill. We touched on direct fill gensets a couple of slides ago. Direct fill can be used if the belly tank or day tank meets the required runtime hours required by the owner. So if the owner wants 24 hours of fuel for their generator and you can put that much fuel into a belly tank, you're good to go. The only other requirement is that a supply truck needs to be able to reach the fill port. And typically the hoses on a fuel delivery truck are about 50 feet long. So if you can get enough fuel in a belly tank to meet the owner's runtime hours and the belly tank's located close enough to an access road that it can be topped off directly, then direct fill will work for you. In most jurisdictions, if the driver can see the tank they're filling, no electronic alarms are required. It's just like filling up your diesel truck. If you are using a fill box to get through a wall, or maybe you have an underground tank, NFPA 30 and most fire marshals will require an audio visual alarm at 90% tank full and some means of positive shutoff at 95% full. The two most common ways of doing this 95% shutoff is with an overfill prevention valve that's basically a toilet type float valve that sits inside the tank and lifts up a float that closes the valve when you hit the 95% level. The other way is to use a 95% switch in the tank that energizes a normally open solenoid valve in the fill line. And a pro tip is to set the switches and set the OPV so that it shuts off at 93 or 94%, because the fire marshal doesn't care if it goes off a little early. They will red tag you if you don't close off the fill line until 96%. They can be sticklers about that. Preferred offers a digital display that talks to the tank gauge so the driver and the owner can see how much fuel is in the tank from the fill box. And this can come in handy in remote fill situations. Now, a little bit about fuel trucks. There's two types. Gravity trucks, there's one pictured here, are the most common. They offer the largest storage capacity, but they usually do not have onboard pumps. So they're great for filling underground storage tanks, but if you want to fill an above ground storage tank using a gravity truck, you will need a fill box with a pump in it. Preferred offers a flex fill box with a variety of different pump sizes integrated into the fuel system. I have seen larger trucks like this with pumps on them, but it is rare. Usually they fill by gravity alone. The other type of truck is a Bowser truck, named after the guy that invented them. They're typically 2-axle. They're limited to 5,000 to 6,000 gallons of fuel, and they include a pump to fill an above ground storage tank. The fuel pump on a Bowser does not have enough head to fill a rooftop tank, so you'll still need a pumped fill box for these applications. This is what the preferred pumped fill boxes look like. The bottom enclosure is to catch any spilled fuel or to catch fuel out of the fill pipe if the fire marshal requires the fill pipe to be dry when not filling. We covered direct fill gensets. Now we're going to cover larger fuel systems with main storage tanks, transfer pumps, or remote fill day tanks. Pictured here is the most common type of above ground storage tank, the horizontal cylindrical tank. These are available up to at least 40,000 gallons. The job I was on last week had 11 40,000 gallon above ground tanks, which I think are the biggest I've ever seen. Above ground storage tanks, or ASTs, can also be rectangular. It seems like the smaller tanks are more often rectangular. And both cylindrical and rectangular tanks come in 3 flavors. There's the UL 142, UL 2085, that's 2-hour fire rated, and ballistic rated tanks. Your local fire marshal or the owner's insurer will tell you when fire rated tanks are required. Ballistic rated tanks are usually requested by the owner. Ballistic rated tanks are common with telecommunication equipment in rural areas where my redneck countrymen use anything round or rectangular as a target. I think ballistic tanks are rated to take a round from a 30-06. When we size the main storage tanks, the first thing we need to do is convert desired runtime hours to gallons of diesel. It's an easy calculation, but people unfamiliar with tanks might forget you can only fill a main tank to 90% full. And there's some oil at the bottom of the tank that isn't usable as well. The drop tubes do not go all the way to the bottom of the tank, so there's unusable fuel at the bottom of the tank too. The quick rule of thumb for genset consumption is multiply genset kW by 0.07 to get genset consumption in gallons per hour. So for every 100 kW, you're going to have about 7 gallons per hour of fuel. Actually, it seems like the most common genset I deal with these days is a 2 meg, and a 2 meg usually draws 142 gallons per hour. So 0.07 plus or minus a little bit. So ullage is the air gap at the top of the tank. The fire marshal won't let you fill a main tank past 90 or 95%, so you can't use that tank volume as part of your runtime hours. Drop tube gap refers to the oil at the bottom of the tank below the drop tube. Typically, that's another 10% of the total tank volume. Preferred has a web app that makes this calculation even easier. You enter your generators and their kW, you enter your desired runtime and the percentages at the top and bottom of the tank that you can't use, and it tells you the nominal tank gallons that you need. The next step is to determine how many main tanks to use. One large tank may hold enough fuel and is the least expensive option, but there may be reasons why you may want more tanks, including redundancy. There aren't a lot of things that go wrong with main tanks, but you may want to split your fuel up into 2 tanks so that you'll have a second tank if something goes wrong with the first tank. Also, available real estate may come into play. It may be easier to fit more smaller tanks than one large tank. And then finally, there may be transportation and rigging issues with one large tank. It may be impossible to get one tank to the site and into position, so you'll have to use 2 or more smaller tanks. When you're calculating the amount of diesel you need to meet your runtime requirements, don't forget you can include the oil in the day tanks or belly tanks. A project I did last winter involved adding 2 20,000-gallon main storage tanks to a facility that already had 2,500-gallon base tanks. 2,500 gallons times 6 generators is a lot of fuel, but it didn't get them through the February freeze in 2021, so they added main tanks. But from the owner's runtime requirements, day tank fuel is the same as main tank fuel. It all gives you more generator hours. Also, you may want to consider what type of emergency you're designing for and what the likelihood is that fuel trucks will be running. I joined Preferred, I think, in 2006, and that was the same year as Hurricanes Katrina and Rita. And in Hurricane Katrina, all the causeways and bridges into New Orleans were damaged by the storm surge, so fuel trucks couldn't get to the gensets in Katrina. Hurricane Rita followed about a month later and primarily hit East Texas, Houston to Beaumont. And Texas was able to clear the roads and keep the fuel trucks running. In Hurricane Sandy, all 4 of the major hospitals in Manhattan had to be evacuated because the fuel systems eventually failed and they couldn't get fuel trucks down into Manhattan after the flood. In Hurricane Maria in Puerto Rico, there were so many down power lines and down trees that for the most part, the fuel trucks weren't running. And in the 2021 Texas freeze, the roads were open, but there just wasn't enough fuel trucks. Dual fuel boilers were curtailed on natural gas and forced to use oil. And with all the hospital boilers running on oil, the fuel trucks were busy dropping off fuel to hospitals, which are first priority, and some data centers tried calling for fuel and weren't able to get fuel deliveries. So this is something you need to keep in mind when determining your runtime hours. A lot of federal facilities now they have a new mandate that they want to have 2 weeks worth of fuel on site in case they get into a disaster where the fuel trucks aren't running. And that's a lot of fuel, especially if boilers are using that fuel too. So these are the typical accessories you're going to see in a main storage tank that you need to specify. Going from left to right, there'll be a return pipe. This is for fuel coming back from the day tanks. We always want to have the return pipe on the opposite side of the tank as the transfer pipe suction tube. That way we get good mixing in the tank. The next item from left to right is the fill pipe, shown with an overfill prevention valve in it. Then you're going to have a vent and then a high level alarm. This could be your 90 or your 95% switch or both. You're going to have 2 emergency vents, an access cover, a main pump suction with a foot valve at the bottom, filtration suction if we're going to have a filtration system or a polisher on the main tank. And then finally, at the end of the tank, there's going to be an interstitial leak sensor. It's required by code, and it can either be a float switch or a discriminating leak detector type switch. Oh, and I missed the level transmitter. So the level transmitter sends a 4 to 20 milliamp signal out proportional to the level, and then that oil level gets converted to gallons in the tank gauge. And what's shown there is a wire float level transmitter, but you can also do a head level transmitter, a continuous level sensor, or an ultrasonic level transmitter. So now that we know the basics of a genset fuel system, we're ready to talk about transfer pumps and transfer piping. The schematic shown now is the basics of a single main storage tank, single genset system. The lead transfer pump pulls fuel from the main storage tank, in this case an underground tank, and goes directly to a day tank. The genset fuel pump pulls from the day tank and returns excess fuel directly back to the day tank. There's a foot valve in the main tank to maintain prime in the suction line, and there's a flow switch at the discharge of the pump set. If the lead pump doesn't prove flow, the alarm sounds and the lag pump is energized. If it doesn't prove flow either, both pumps are de-energized and the common alarm stays on until silenced. And recall, there are 4 float switches in the day tank to run the pump controls. The most common reason that the flow switch doesn't prove flow is that somebody closed a hand valve in the system. And you know, a hand valve can cut off fuel to a generator just like a failed solenoid valve. So anytime there's a call for fuel and we're not delivering fuel, we want to sound alarms. This is typical suction piping for an above ground storage tank. You'll notice it's exactly the same as the underground storage tank, except we've added an anti-siphon valve. Many people are tempted to use a solenoid valve in place of the anti-siphon valve, but you really shouldn't. A solenoid or a motorized valve doesn't quite serve the same purpose. The point of an anti-siphon valve is if you get a break in the line or a union that didn't get tightened up, or you know, a plug that doesn't get plugged, in the suction line below the level of stored fuel in the main tank, you can drain the entire tank down to that level through siphonic action. And the anti-siphon valve works sort of like a check valve. It's sized for the height of the main storage tank, and the spring is sized so that siphonic action won't open up the valve, but energizing a pump and all the suction that goes along with that will open up the valve and allow oil to flow. So Preferred makes anti-siphon valves with 4-foot springs for the line between a day tank and a genset. We do 5-foot springs, 10-foot springs, and 20-foot springs. So we know how big our main storage tanks need to be now, and we know how many main tanks we're going to have. Next, we need to size the transfer pumps that will pull the fuel out of the main tanks and push it into the generator day tanks or belly tanks. Generators consume about 7 gallons per hour for every 100 kW of capacity, or you can multiply the kW by 0.07 and get very, very close, regardless of who made the engine. You want to apply a generous safety factor to the transfer pump sizing because you want to be able to top off a day tank or a belly tank relatively quickly and let the supply pump cycle off. Preferred will apply a safety factor of 3 to 4 on top of generator consumption, and then calculate how long it takes each pump to go from 50% pump on in a belly tank to 80% pump off. So sizing that might look good for a 200-gallon belly tank system, you may want to use larger pumps with bigger belly tanks, like 4,000 or 5,000 gallons, because our flow will be more than generator consumption, but you don't want to spend all day topping off a belly tank. You want the tank to top off in a reasonable amount of time, and then let the pump cycle off, or let the pump be available to top off another belly tank. Also, once a year, your poor fuel service technician is going to run the fuel to all four of these float switches and make sure they still work. So the bigger the transfer pumps and the return pumps, the faster that goes. And we're talking about very small pump motors and a very small difference in price from one pump set to the next. So Preferred has another web tool to help size the suction lines, discharge lines, strainers, and anti-siphon valves for a typical remote fill system. You can get to it just by Googling Preferred pump and pipe sizing web app. And the first thing that you do is you put in your geometry of your tank versus where your pumps are located. And then you can put in your pump size from either a pull down menu, or you can put in a custom pump size, whatever flow you have. And then you put in your elbows, your T's, all the different types of valves. And then the line size is just from a pull down menu. So if you try 1-inch piping and the green turns to red, indicating that you've exceeded the limitations of the pump, either on the suction side or the discharge side, just go to the pull down menu and bump it up to 1 1/4 or 1 1/2. Once you get your pipe geometry in, you can change from one line size to another relatively quickly. The same with changing pumps. These are the transfer pump sizes that we stock, from 23 gallons per hour up to 1,930 gallons per hour. We can make larger pump sets, but they're not in our catalog. Also, these pump sets are shown for 50 PSI or 100 PSI discharge. If we're doing a high-rise application with gensets on the roof, we can use rotary screw pumps for high-pressure applications. And when you're using the pipe sizing program, as a rule of thumb, if your gensets and your transfer pumps are all on approximately the same level, an outdoor system like what we typically have here in Texas and flyover land, you're probably going to want 50 PSI discharge pumps, because you don't have a lot of vertical you need to push the oil up. I typically see 50 PSI pumps up to gensets on the first or second floor. Beyond the first or second floor, you're probably going to be into 100 PSI pumps. And then if a 100 PSI pump isn't going to do it, take a look at your line sizing. The output from the Preferred web app tells you, your friction losses through the pipe, through the valves, and your vertical hydrostatic pressure too. So if you're doing a system that's 10 floors or less and you're seeing 100 PSI discharge, your piping is probably undersized. And the same is true too. If you're doing a system that's all on the same level and you're seeing a discharge pressure more than 50 pounds, then your piping is probably undersized, because the vertical just isn't that much. We also offer all the pumps on the previous slide in waterproof enclosures that have been tested to 90 feet of seawater inundation. We developed these after Hurricane Sandy, and we've installed them, a lot of them in New York City, in Boston, and now Florida. If we have multiple main storage tanks, the tanks are going to be piped in parallel so that either pump can pull from either main tank. Tank select valves are used to line up the tank we want to draw from. Day tanks will be piped in parallel as well. The day tanks will have an overflow line back to the main storage tank. In the case of underground storage tanks, the return lines can use gravity return. With above ground storage tanks, return pumps are used to push the fuel from the day tanks back to the main storage tanks. Tank select valves in the return line will ensure returned fuel goes back to the same tank we're drawing from. Occasionally we'll get a customer or an engineer that wants to use the transfer pumps to move fuel from one tank to another, and we really resist this. When you can use the transfer pumps or the polisher to move fuel from one main tank to another, it introduces the possibility of overflowing a main tank. And we've got switches and automatic safeguards to prevent that from happening, but we'd rather not tempt fate. So we always want to pull from the same tank that we're returning to. And we've had customers, like in Hurricane Rita, we had a customer that ran their gensets for 14 days. And the sequence we recommend most customers use if they're going to be running their gensets for a long period of time is to run tank 1 until it hits low level, 10 or 20%, and then switch over to tank 2. Call for fuel and get tank 1 topped off, and then polish all the fuel in tank 1. You want to polish the fuel after you get a delivery, just on the off chance that you get a delivery of bad fuel. It's very rare, but sometimes you do get a delivery of fuel that has water in it or doesn't pass the clarity test. So it's very rare, but when your gensets are the only thing powering your hospital or your data center, you don't want to take any chances. So then when UST or main tank number 2 gets down to low level, you switch over to tank number 1 because it's full and that fuel's already been polished, and then call for a delivery in tank 2. And when you're using this sequence, there's never any reason to move fuel from one main storage tank to another. When you have multiple day tanks connected in parallel, you'll need a flow control manifold to direct fuel only to the belly tank calling for fuel. The diagram shown here is the most basic form of flow control manifold. If you like, you can build on this by adding a second solenoid valve or replacing the solenoids of motorized valves, or you can add a strainer or a flow switch or a site flow indicator. But what's shown here is pretty much our basic flow control manifold. The 3-valve manifold, the hand valves around the 2 solenoid valves are important. They let you replace a solenoid valve without interrupting fuel supply to the generator in an emergency. It also allows you to open the bypass valve and put a pump in hand to fill a generator in the event of a controls failure. So anytime preferred supplies a pump, you're going to see a handoff auto switch on the enclosure that has the motor starters for that pump. And then the equivalent of the handoff auto switch is this 3-valve manifold here that lets you bypass the solenoid valve. So in the event that there's a problem with the controls or something, you can still get fuel to a generator in hand. So gravity return lines are required to be sized so that they'll flow more oil than your supply lines. When gravity won't work for you and you're putting return pumps on the day tank, your return pumps have to have greater flow than the supply pumps. So Preferred offers a variety of pumps. Some of these are the same pumps we'll use in the supply pump sets, and then some are actually high flow, low head pumps that we usually use in our polishers. But they're available in higher flow rates than our supply pumps. So this is the outline of the sequence Preferred uses for filling day tanks. When the tank level gets down to 50%, we bring on a supply pump and open the fill valve and start filling up the tank. At 80%, the fill valve de-energizes, and if no other day tanks are calling for fuel, the supply pump shuts off. What can be confusing for some people is if their oil level is between 50% and 80%, the Preferred pump set doesn't take any action. We don't top off the tank until it gets down to 50%. There will be a soft button on the touchscreen for the supply pumps that's called a top off button. So if you want to, you can push that soft button and the controls will automatically top off the tank to the 80% level. But it's normal. And if you're just doing kind generator testing every once in a while, it can take you a long time to get from 80% down to 50%, and people get worried that they haven't seen their supply pumps come on. But it's normal for them not to come on until you reach the 50% level. But if you're getting a fuel delivery, or you're nervous, or you're located in Houston and there's a hurricane in the Gulf of Mexico, you can hit all of your top off buttons and top off all your day tanks to 50%. And then when you top off your main storage tank, you'll have more room in the main storage tank and more fuel in your overall fuel system. If the fuel level gets down to 40%, which it shouldn't, but if it does, we sound the alarm and we energize both supply pumps to increase the flow to the day tank. If the fuel level gets to 90%, we sound the alarm, we hardwire de-energize the fill solenoid valve on a multiple day tank system. If it's just one day tank connected to a transfer pump, we will hardwire de-energize the pump motor starters as well, and we'll energize the return pump. And then with all three of those things going on, your level should get down to 50% pump on, the return pump will shut off, and then the system will top itself off again to 80%. But we sound the alarm because if the 80% float is working correctly, there's no reason the oil should get to 90%. So it indicates some sort of an upset condition, and we'd like an operator to come out and take a look at it. So moving on to leak detection. Leak detection is required in tank interstitial spaces. It's required in containment piping. It's required in sumps. A lot of times customers will ask us to put leak detection in rupture basins, like under the transfer pumps or in the enclosure where the fuel polisher is. Or sometimes we'll just put a float switch in a basement generator room to let people know when there's flooding, either with water or with oil. Pictured on the left is our PS LDS, and on the right is the RBS. They're both just float switches that are made in the down position and break in the up position when a leak is detected. We use them interchangeably depending on which is easier to install for whatever device. The other leak detector we use is our discriminating leak detector. The part number is HDA2C. It has an optical leak detector, and then, well, you can't see it very well in this picture, but there's two little rings on the end of that plastic leak detector, and those rings sense conductivity between them. So if the optical sensor sees something and the conductivity sensor says that we see conductivity between the two rings, then the water LED lights up, and we send a 4 to 20 milliamp signal that's interpreted as water. If there's oil present, or I'm sorry, if there's fluid present and there's no conductivity between the two little rings, then it interprets that as oil, and it lights the oil LED, and it sends a different 4 to 20 milliamp signal back to the tank gauge that gets interpreted as oil. So these are handy, especially in underground storage tanks, where if you get a rupture in the outside of the tank, it's going to leak groundwater in, and if you get a leak in the primary tank, it's going to leak diesel fuel out. And this will let you know whether it's oil or water that's detected. So the last topic we're going to cover is diesel fuel degradation. Diesel fuel is a hydrocarbon that begins to decay as soon as it's refined. There are bioorganisms that come in through the air in these vented tanks, and they live at the oil-water boundary at the bottom of the tank. They actually live in the water and they eat the oil, and they make a bacterial sludge that can gum up strainers. So another byproduct of the sludge formation is organic acids that can corrode tanks and seals and other instrumentation. And because water is heavier than the oil, the water sits at the bottom of the tank. So Preferred makes fuel polishers that I think they start at 480 gallons per hour and go up to 1,200 gallons per hour, that will strain the chunks out of the fuel and get rid of all the sludge, and they'll take all the water out of the fuel. And the water is the most important ingredient to keeping the fuel viable over the long term, because if there's no water in your fuel, there's no place for the bioorganisms to live, and they won't be making that sludge that can gum up your engine or can gum up your strainers. So we get a lot of questions from engineers and owners about whether they should specify a fuel polisher with their system. And the questions that we ask is, how quickly will the fuel be turned over? If it's a typical genset only fuel system where we're just going to see short generator testing, then you're typically not going to consume enough fuel to keep your fuel fresh. And in that application, you're going to want a polisher. How cost sensitive is the customer? Polishers are pricey, but they're permanent, and they will clean your fuel, but some customers that just don't have it in their budget. Also, humid environments are more likely to need a fuel polisher than dry environments. Here in Texas, especially in South Texas, we have days where you go out in the morning and it looks like it's rained, but it hasn't rained. It's just been condensing all night long because the air is so moist, and for some reason the ground is cold. These main storage tanks are vented to atmosphere, so if water is condensing on the ground, it's going to be condensing in the cold steel of the tank too, and that water brings the bioorganisms with it, and it goes down to the bottom of your tank and causes a problem. So these are the three considerations really for whether your system should have a fuel polisher. All that being said, virtually all of our data center projects now have fuel polishers on them. And even though our polishers can do 1 or 2 tanks, most of our data center customers want 1 polisher per tank. And they're provided with a little control system that has like a sprinkler timer in it. So you can set the polisher to run. You can set the day of the week, the start time, the run duration to run as much as you want. And I'll usually set it up, a polisher, to run 6 hours or so twice a week. And then when we do a preventive maintenance on a tank, we'll always take a bottom sample from that tank, because that's where the water is going to be and that's where the sludge is going to be. And if we have a job with a polisher and there's still a little bit of water at the bottom of the tank, I'll up the polisher hours per week to make sure it gets pulled out. But some of it's seasonal. In certain weather, you're going to condense more water than other weather. So that, with all that being said, we have never had a problem with fuel quality on a job that had a polisher. So getting the water out of the fuel seems to be the most important consideration. So this picture shows an inside view of a preferred polisher. The fuel flow here is from left to right. So we come in on the left through a ball valve for isolation, and then we go through a simplex strainer. And the purpose of that strainer is to get the chunks out of the fuel to protect the pump, because the pump is the next device in line. So there's a DP switch across the upstream strainer that will tell the control system when the switch opens, and that means that strainer is full. And then you can go look at the gauge and see which strainer it is. And the upstream one has a basket that you can dump. Downstream of the pump is the coalescing filter that takes the water out of the fuel and does the final filtration on the fuel. And that has a replaceable element in it, and that element can go from 1 micron filtration up to about 20 micron filtration. And our standard is 10 micron filtration. It also has a DP gauge across it, so you can watch as that filter gets more and more filled, and it has a switch. So if you're ignoring the gauge, the switch will eventually open, and the control system will go into alarm and tell you that your downstream filter needs to be changed. And then finally, there's usually a leak detector in these to tell you if we've got an oil leak, and then an outlet ball valve. The fuel polisher should have its own fuel oil supply line. And the drop tube for the polisher should go all the way down to the bottom of the tank, because that's where the water, excuse me, and the microorganisms live. The drop tube for the supply pumps will typically be 6 to 8 inches above that, where the fuel should be clean all the time. Okay, so now you know quite a bit about genset fuel systems. There's a lot more to this depending on where the site is going to be located. There's also considerations for heating fuel in cold climates, which includes DFW now. And there's considerations for cooling fuel oil in the summer in climates that are hot, like DFW. So we have webinars that talk about fuel oil handling systems in cold and hot weather that you can check out on our YouTube page. And I'm going to shut up and we will take your questions now. Thanks everybody for attending. So we've got quite a few questions. Using a fill station to fill the day tank, do the level switches and alarms communicate to the fill station controls? Yet, sometimes yes, sometimes no. I have seen pretty dumb fill stations that are just a cam lock fitting in a little enclosure on a pedestal, and that's it. If Preferred supplies a horizontal fill box, like what was in that picture with the fill truck, we will put an alarm horn and a light there that ties into the tank gauge to alert the operator when he's going to overfill the tank. The same is true of our sidewalk fill box that we didn't really show. Also, we make a Model 226 overfill alarm enclosure now that just generates the 90% alarm and then energizes a relay contact to close a normally open solenoid valve in the fill line at 95%. So virtually anything you're going to buy from Preferred is going to have overfill alarm built into it at the fill station. But there are other manufacturers that make fill boxes with no electronics in them at all. And you can still purchase the Preferred 226 version for that and just locate the alarm enclosure where the truck driver can see it. We also make the FAAV that does something similar. The question here, 2080 versus 2085. I think this is referring to UL 2085 tanks. If I said 2080, I misspoke. The code is UL 2085. When are foot valves needed in tanks? So a foot valve is like a check valve that goes at the bottom of the drop tube, either in a main storage tank or it could be in a day tank too. And the idea of that check valve is to keep the flow from reversing and allowing all the oil in your suction line to run back down into the tank. So they're needed virtually every time. And we make a single poppet version and a double poppet version that's kind of like a duplex to make sure that one or the other seals. The only drawback to the double poppet foot valve is that it's a little more pressure drop across the valve. But you're always going to need a foot valve to prevent you from losing prime. When are anti-siphon valves needed versus using a solenoid valve? This question came in before we got to that slide, but just for review purposes, the anti-siphon valve prevents draining a tank through siphonic action if you get a break in the line below the level of stored fuel. And we always prefer to use an anti-siphon valve in that application, but Preferred's anti-siphon valves only go up to 1,100 gallons per hour, and we make pumps. Our LO207s, which seems to be the most popular pump for me lately, has a flow of 1,932 gallons per hour. So in those situations, we're usually going to have tank select valves on top of the tanks anyway. So we will use a motorized ball valve or a big solenoid valve as the tank select valve, and it also performs some of the functions of an anti-siphon valve. We typically do not open that valve unless we're calling for fuel from that tank. How would you deal with the fuel oil return line coming from multiple generators on a roof to multiple bulk storage tanks in the basement? Can you valve or solenoid control the return line back to a specific tank? Code says must be free flowing. This is a really good question. The code that we're trying to follow here is NFPA 37, and NFPA 37 is written around gravity return. And it states that your gravity return line must be able to flow more oil than your supply line. So that if you get a pump stuck in hand, for instance, and nobody's there to respond to the alarm saying you're overfilling the tank, you can drain more oil out of the tank than you're putting in, which seems reasonable. What NFPA 37 doesn't cover is the very common situation with above ground storage tanks where gravity return isn't going to work because the top of the tank, the up and over to go back into the tank is higher than the day tank. So our interpretation of NFPA 37 in that instance is that you need a return pump, and the return pump will be sized for more flow than what we can put into that day tank or that belly tank. And the questioner, the person who posted this question is correct. NFPA 37 says you can't have any restrictions in that line, but NFPA 37 doesn't anticipate return pumps, and it doesn't anticipate above ground storage tanks even, and it doesn't anticipate multiple main storage tanks. So what we do is if we have multiple main storage tanks that are connected in parallel, which is all the time on the bigger data centers that I do, we put tank select valves on the supply and tank select valves on the return line. And we use motorized ball valves with actuators that have proof of closure and proof of open switches. And we prove that the valves are in the right position before we energize the pumps. You can take this one step farther. Again, we're going way beyond what the code was written for, but sometimes we will put flow switches in the return line as well. And that proves if we energize a return pump, the controls look for that flow switch to open, proving flow, which is a trick I learned 2 or 3 years ago, and I think it's a good idea, and we do this now on most of our larger data center jobs. The main thing to look out for is a hand valve. The controls don't know where a hand valve is, so somebody at the facility can close a hand valve for whatever reason, and then not open it again, and now the return pump won't flow oil. And if there isn't a flow switch in that line, the controls aren't going to know about it. Now, if a return pump is energized, an alarm's going to be energized too, because the return pumps come on at 90% and our pump off level is at 80%. So the oil should never get up to 90% in a normal condition. So we're going to be sounding the alarms anyway. That's a good question. We get that one a lot. Any special design considerations if generator and day tank are located on the roof? I don't see that many of these systems because I'm in Texas and we have plenty of real estate and everything is usually at ground level. In New York City, we do a lot of systems with gensets on the roof, and we just need to make sure that we size the pumps for the head to get the oil all the way up to the roof. In most jurisdictions, if your oil line is going to go through occupied spaces, it needs to be double wall contained with a leak detector at the low point. And then a lot of times we will use kind of a standpipe system to pressurize the oil going into the day tank rather than a back pressure regulating valve. If this is a question coming from New York City, I'll put you in email me and I'll put you in touch with John Haber, because he's our New York City guy, and a lot of the rules are different in New York City. And I don't profess to be an expert on New York City rules, but John is. Does above ground piping need to be heat traced in cold weather areas? That's a great question. And we just had some particularly nasty weather here in Dallas the past couple of weeks. We got down to about 12 degrees. And after the freeze of 2021, we installed 7 pump and heater systems. No, 8 pump and heater systems here in the Dallas area. And one of them needed a little bit of hand holding the Sunday before last, because it was the first time it had been run in really cold weather. So I got to put on all my ski gear and go out and troubleshoot this system in 14-degree weather. So that was fun. Heat tracing is one of about 4 different things you can do to heat oil. And we did a whole webinar on cold weather fuel systems that you can find on our YouTube page, where Alex Canny and I are your local preferred guy in the Northeast United States. He's located in New Hampshire, I think. We talked about all the different technologies. And what Preferred likes to do is we like to add electric heaters to our pump sets. And then we use a routine where if the ambient air gets below set point, typically about 40 degrees, then we'll start a pump and start a heater and start circulating fuel between the pump and the main tank. And then one at a time, we will energize a return pump and pump a day tank down to the 50% pump on level, and then let the transfer pump oil back to the 80% pump off level. And that keeps the overhead lines warm, which is the danger area, because that's what's going to cool off the fastest is your overhead lines. It keeps the day tanks warm and topped off with warm oil. And then that recirc function recircs a little bit of warm oil back to the main storage tank to keep the main storage tank warm. And this is really the best way to do it. Heat tracing and insulation of your overhead lines is good because it's much less expensive, and it's going to take care of the weakest link in the system, and that's the overhead lines. Overhead lines, especially when they're not double containment, are going to get the brunt of the cold, especially in the wind. And if that fuel gels on the line, the pumps may not be able to push that gelled fuel through to a day tank. So, your main tank has a lot of volume and a lot of thermal inertia. So the main tanks are going to take a long time to cool down, but those overhead lines are going to cool down really quick. So they are the most vulnerable part of a fuel system, and heat tracing and insulating those lines is an inexpensive way to protect the most vulnerable part of a fuel system. And one thing I learned in 2021, like the first day that cold front came in, we had temperatures in the low 20s, and I had a customer saying they had gelled fuel. And diesel fuel typically gels at 18 degrees, and we hadn't gotten that cold yet. We were going to in a day or two, but we hadn't gotten that cold yet. The site wasn't far from my house. I went out there, and it did look like the fuel was gelled, but what it was is they had water in their fuel that was getting nicely mixed up by their transfer pumps. They were running their pumps to try and keep the fuel moving, and that was mixing up all this water. And when the oil went below 32 degrees, the water in the fuel turned to ice, and the ice kind of agglomerated together and made it look like gelled fuel, but it wasn't. So you'll read that diesel fuel gels at 18, but if there's water in the fuel, it can gel at 32, or essentially gel. It can start to freeze at 32. So so bear that in mind. Okay, next question. With different spring pressures drop available in the anti-siphon valves, how is designed to determine which one to use? You're going to use the spring that correlates with the height of your main storage tank. So if you have a 10-foot diameter storage tank, and the lowest point in your line then is going to be ground level or close to it, and then the top of the tank is going to be at 10 feet. Use a 10-foot spring. If your pumps are up a little higher, like on a pedestal, you might use a 5-foot spring in that application. If you want to put an anti-siphon valve between the day tank and the genset itself, the day tanks aren't very tall, so you'd use a 4-foot spring in that application. And you want to use you don't want to oversize that spring, because that spring takes quite a bit of pressure drop in the suction line, and we're limited by how much suction we can generate with the pumps, so we don't want to overdo the spring in the anti-siphon valve. Next question, is a password needed for using the preferred pipe sizing program? No, there's no password. You just go to it. If you want to save your work, it's going to ask for your name, your company, your email, and your telephone number, I think. And then a lead is going to show up on our website. And then I go through these leads every single day, and then I'll pass that information off to your local preferred person, who will usually send a quick email saying, I see you used our pump and pipe sizing program. Did you have any questions? And if you have any questions, they'd be happy to help you. And if you're fine, just don't respond to the email. We don't share that information with anybody else. But there is no password. Next question, what are the 2 solenoid valves for on the flow control manifold? The 2 solenoid valves are basically a belt and suspender approach. You can get by with just one normally closed solenoid valve that is energized by the pump controls system. I was on a job last week that had 2 normally closed solenoid valves energized by the pump controls, just for redundancy. And then sometimes we will do a normally closed valve and a normally open valve, and then the normally open valve is energized through the leak detector in the day tank, somewhat independently of the pump set controls. So if we detect a leak in the day tank, that second valve closes, and that day tank doesn't get any fuel anymore. That is not a code requirement. It's just something some of our customers ask for. Next question, what are the concerns when utilizing boiler heating oil as emergency generator diesel fuel? Boilers are a lot less sensitive to different fuels than diesel engines are. So on Preferred's burner side, we make burners that burn a wide variety of liquid fuels. But the most common fuel you're going to see for boilers is number 2 diesel, and that's the exact same thing that's used in the gensets. I would not burn anything but number 2 diesel in your genset without checking with the engine manufacturer. I think I've heard of running gensets on Jet A fuel, but again, I would definitely clear it through Caterpillar or Cummins or Onan, whoever supplied your generator, before you put some kind of weird fuel through. But at least 90% of the boiler fuel out there is number 2, which is the same as what goes in your genset. In the Northeast, there's a big push to run biodiesel, and Preferred's pump sets now are approved for biodiesel, and we're working on burners that are UL listed to burn B100, 100% biodiesel. But again, I would check with the manufacturer of your engine before you burn biodiesel in your genset. And it's just like when they started putting ethanol and biodiesel in our car and truck fuel. If there's any rubber seals in any of the fuel lines, that's not going to react well with either biodiesel or ethanol. So that's the main thing, is to make sure there's any rubber that'll swell in the presence of biodiesel. How is the sludge cleaned out of the bottom of a day tank or belly tank? The short answer is it usually isn't. So we usually just polish the main tank. We have done projects with very large belly tanks where we put a small polisher on each belly tank to polish the belly tank fuel. the alternative too is sometimes we will do a fuel polisher on a fuel system that's tied into the pump controls, so that sort of like what we do with the thermopump system, we'll pump each day tank down to the pump on level, and then top it back off with polished fuel from the main tank. And this allows you to turn over the fuel in the day tank and help keep it fresh. Typically, the drop tube for the return pump doesn't go all the way down to the bottom of the tank, though, so you're not going to get all the water and all the sludge out. And you just kind of hope that the mixing action will churn that up a little bit so that the polisher can catch it. But there are options for doing that. It's just that all the options cost money. So it depends on how big your belly tanks are and how important it is to get that stuff out from the bottom of the tank. And that's a good consideration because the oil in belly tanks just seems to sit for long periods of time. And even if you do generator runs every once in a while, you know, a quick generator test doesn't burn very much fuel. So the oil in your day tank can be relatively old. So in those situations where we have large belly tanks, we will usually do the sequence where we'll pump down the belly tank and get the old fuel out of it and top it off with fresh fuel that's been polished from the main tank. So the next question, and I think we only have a couple more. How can a fuel polisher prevent fuel degradation? It's removing water and sludge, which are contaminants. The main thing the polisher does is get rid of the water. If you recall the picture we showed of the inside of the fuel polisher, there's a basket strainer there that is designed really just get the chunks out before the oil goes through the pump to protect the pump. And then there's a coalescing filter downstream of that usually filters to 10 microns and removes all the water. And that's going to take care of that's going to take care of biodegradation. You know, bioorganisms living in the water and eating the fuel and creating sludge. And that's the most important thing in preserving the life of your fuel. If you wanted to do more, I would recommend they make additives and preferred sells them that can reduce the thermal degradation of the fuel as well. We used to package these with a biocide, and then we found that low levels of biocide in your fuel all the time can actually you can develop biocide resistant bacteria in your tank. And if you get that and the biocide isn't working, then your tank has to be drained and professionally cleaned before you can put fuel back into it. So we don't recommend a biocide anymore, but a fuel stabilizer to reduce the thermal degradation is a good idea. If we see that you have a biologic outbreak in your tank, we'll hit it with a ton of biocide all at once to completely kill it. It's just like antibiotics. You know, doctors are not prescribing low levels of antibiotics anymore because we made antibiotic resistant bugs. So now they put you through a big course of antibiotics and tell you to take all your pills. Next question, are fuel oil pump systems expandable? For example, if for a hospital, multiple boiler gensets are to be installed upon a future building expansion, how can the fuel oil pump system be set up to be expandable? We actually did a webinar on this too. And it's on our YouTube page. This is the most difficult fuel system design that we run into. You know, anytime we can start from a clean slate, it's easier than adding on to what is already available at a hospital. And a hospital is a good example of that because the hospitals seem to always be adding wings or just adding gensets or adding boilers. So I think I'm going to take the easy way out of this one and refer you to the webinar on our YouTube page, because we spent about 45 minutes talking about this. And if I recall, we tried to classify these projects into like 4 basic types. And I know we covered, you know, adding another wing to a hospital. So please check out our YouTube page for that. Next question. I think there's only a couple more. When routing from an outside filling pump station into a building up to a rooftop belly tank, does that piping need to be containment pipe with leak detection? The rule of thumb is if that piping is going to go through an occupied space, you're going to need to have double wall pipe. And in most places, we will put a leak detector at the bottom of the interstitial of that double wall pipe, and an alarm if that leak detector goes off. They allow something strange in New York City where you'll have double wall pipe, but the bottom of that pipe isn't welded shut. Instead, it's drained into a 55-gallon drum, and then you put a leak detector into that drum. So in New York City, I guess you need to hope it's not a huge leak and that you can respond to it and shut off the system before you overfill your 55-gallon drum. Most every place else, that containment piping is going to be 100% welded, contained, and if you do get a leak, you're just going to fill up that containment piping, and alarms will be going off. So that's actually the short answer. The correct answer is check with the authority having jurisdiction, and that's your local fire marshal, because what I gave you are rules of thumb. It could be different where you are, and that's an excellent thing to run past your fire marshal, because that can change by jurisdiction or by location. Do you usually provide fuel supply and return in one containment pipe if required, or do you run your supply and return in separate containment pipes for each line? In most jurisdictions, you can do it either way, and it's less expensive to run both your supply and your return in one containment pipe. And in fact, I think there's prefab piping that has like an outer steel wall, and then an inside is hydraulic hose that has your supply and your return. Our New York City representative, they sell Brugg containment piping, and I think that's an option with them. But code allows you to do it either way, but it's less expensive to put your supply and return in one containment pipe. The next question is, how do you protect the containment pipe for fire protection? Do you use special fire wrap if fire-rated enclosure is impossible? I think you stumped the chump on this one. I've never seen a containment pipe that was wrapped with insulation. But most of the time when I see containment pipe, it's either underground pipe or it's above ground outdoor pipe. In most jurisdictions, outdoor pipe is not required to be double wall contained, but it seems like most of my data center customers want it to be double wall anyway, just for an extra added protection. So I don't know the answer to this, except to say that I've never seen containment piping wrapped. And if somebody knows the answer to this question, or if one of the preferred people listening knows the answer to this question, please let me know, so I won't be stumped the next time this comes up. Thank you. What is a rough estimate for a polishing system? On the low end, they're going to run about $25,000. On the high end, that's a 1,200 gallon per hour unit. They're going to run. Well, hold on, that's list. They're going to run about 20 to 40, I think, depending on the size. And there's There's not a lot of installation required. You set it on a pad. We like the polisher to be as close to the main tank as possible, so the pipe runs aren't that long. And then they just take 120 power. Next question is, what's the best velocity to maintain in pipe sizing? Our rule of thumb is we don't like to go over 7 feet per second in diesel piping. And if you use our pump and pipe sizing program and you stay under 7 feet per second, you'll find that your friction losses and your valve losses are pretty reasonable. What is a good cycle runtime for fuel pumps? There is such a huge range of day tanks and belly tank sizes now that that there's just a huge range in cycle times. I like to be able to top off a tank from 50 to 80% in less than an hour. So, you know, I'll take the day tank or the belly tank volume, multiply by 0.3, you know, the difference between 80% and 50%, and then divide by my gallons per hour, and hopefully come up with a number that's less than 60 minutes. The reason that we say that the supply pump has to take into account both the generator consumption and the size of your belly tanks is there was a job in Florida recently that bought someone else's fuel system, and they looked at generator consumption and they put about a 15% safety factor on their transfer piping. You know, probably just rounded up to the next size pump. And the problem was the belly tanks were 2,500 gallons apiece, and it was taking over 12 hours to top off a belly tank, and the pump was just running all the time. So, you know, I don't have any hard data with regard to how much you should run these pumps, but you know, the more you run them, the less time they're going to last, and the more likely they're going to fail when you need them. So I try to keep the cycle time under an hour if possible. Last question, unless somebody pops a new one in. Is using a temperature sensor in day tanks to cycle cooler fuel necessary in the Northeast? I would say not. I'm based in Dallas, where it gets ungodly hot here for about 5 months of the year. It seems like we had 60 days last summer of 105 degrees, and we don't do what you're talking about in all of our fuel systems here in Dallas, and nobody I'm aware of had issues with hot fuel. What I do like to do, especially if the main tanks are above ground, like they usually are these days, and the day tanks are above ground, is like the question implies, we'll put a thermocouple in the day tank, and then if the day tank temperature, the oil in the day tank gets above set point, we'll activate the return pump and pump hot fuel out of the day tank and top it off with cooler fuel from the main storage tank. The day tanks can heat up, especially if the generators are running, because the generators are returning hot fuel to the day tank. So especially if you have a combination of a very big generator and a small day tank, you're going to heat up that fuel pretty quickly. And if that's the case, we'd like to top it off with cooler fuel. In Los Angeles, there's a city code that says that you can't go over the maximum size day tank you can have is 60 gallons. So you pair a 2 or 2.5 megawatt genset with a 60-gallon day tank, and you're going to be burning almost all, you know, hot fuel coming back from the generator. And LA gets really hot too, inland. So a lot of times what we'll do in Los Angeles is, instead of the genset returning to the 60-gallon day tank, the genset returns all the way back to the main storage tank, so that we're not dumping hot fuel into that little day tank. And that way the generator is always getting cooler fuel from the main storage tank. But that's a really good question. And because I don't do these cooling systems all the time in Dallas, and and I have not heard of a customer that had a problem with hot fuel. I would think in the Northeast, you don't have to worry about it. I mean, you don't have strings of 105-degree days in the Northeast. You have 3 days of 95-degree weather and everybody freaks out. So I wouldn't say it's necessary in the Northeast. So thanks again, everybody, for attending.